All right, guys, last topic on area, and we're going to talk about area of similar figures. And we've kind of hinted at this a couple times. We're going to do that on 117. When we were doing like the area of the regular polygons, like whenever I have a hexagon, it's always the same little triangle that I'm looking at to find the apothem and half the side. It's just scaled up by a certain amount or scaled down by a certain amount, depending on how big or small the shape is. And so there's sort of this relationship between all regular hexagons or all similar shapes that can sometimes make our work a little bit easier. So let's have a chat on page 117. So if I'm looking at similar figures, like I know that they are similar, I mean like all rectangles are similar to each other, then what I can do is I can find their scale factor. So if you remember, we find scale factor by just doing like one side length over its corresponding side. So either big over small or small over big, you can choose. So let's say in this case, we choose to do big over small as my scale factor. If I do big over small, then the scale factor is just 2. And then if we think about finding their areas, because like right now I can find the area of each one. The area here would be 240 units squared. And the area here would be 60 units squared. Which if you think about it is not 2 times as large. It's actually 4 times as large, which 4 is the worst, or 2 is the worst scale factor for me to pick to see this relationship, honestly. But I think it just makes sense that when I find the area scale factor by doing big over small, I get exactly square the amount of the scale factor of the sides. So, and I think it makes sense that it's squared because area is squared. So if I just square the scale factor, then I have the area scale factor, which is pretty great. Because we can use that to help us find missing measures, which we'll do in just a second. But let's start at the top here. So each pair of figures is similar. Find the area of the second figure. So that's super helpful because if I know these triangles here are similar to each other, I can write their scale factor right now. So if I do the scale factor as big over small, then what I have is 6 over 4 or 3 over 2. If I then square that, so 9 over 4, that's the scale factor of the areas. And that's helpful because I can find the area of this triangle right now by doing half base times height. So half of 12, so 6. And that is the area scale factor, small portion. I do not know the big one, and I don't know another side. I could find it, but I don't know it. But then I can set that equal to the area scale factor, also big over small, and then just cross multiply and solve. So if I multiply across, I'll get 4x. If I multiply across here, we get 54. And then divide by 4 to get that the area of that larger one is 54 over 4, which is like 13.25? Nope, 13.5. Oh my word. Unit squared. Oof. All right, let's try a parallelogram. So if I'm looking at the next one, the parallelogram has a scale factor of 5 over 2 or 2 over 5. And so the scale factor of the area will be 25 over 4 squared times as much. And so then I can set that equal to the area of the big one, which I can find by doing base times height, so 30. Over the area of the small one, which I do not know, but I will be able to figure it out, call it x, cross multiply and solve. And so we'll have 25x equals 120 then divide by 25 both sides, and we get that our area of the small one is 4.8 units squared. Man, I should have told you this forever ago. We could have found like the area of one regular hexagon and then just scaled it up. Oops. All right, looking at this last one here, it's a pentagon. And I can find the scale factor right now. It's 3 over 5 or 5 over 3. Let's go small over big for funsies. So 3 over 5, which means that the area scale factor will be 9 over 25 because I got to square it. And I'm going to set that equal to the area of each one, like the actual area. So I know the actual area of the small pentagon is 16. I do not know the area of the big one, but I would love to. So I'm going to call it x. And then we're going to cross multiply. And then we're going to solve. So if I cross multiply this way, man, if I got 16 quarters, how much I got? Is that $8? I can't do it in my head. I think it's $8, so I think it's 800. But I'm just going to be safe. 25 times 16, 400. I was 2 times. 400 equals 9x. Divide by 9 on both sides. It's not going to be super nice, but ew, 4.44 repeating is the area of that big one. And then you don't have to use trig at all. Oh my God, crying face emoji. I'm sorry, I'm watching the circle right now and I can only think of how they say the emojis that they want out loud. That's so tragic that I said that. Oh well, it's on video forever now. Okay, now we kind of were using the scale factors to find missing measures up here, like finding missing area, but you can also use it to find missing sides as well. So if I take a look here, I know the area, and I can find the area of this one. If you remember, it was 240. And so what we can do is we can write our 240 over 60. So this is sort of like our area scale factor. And I feel like I could reduce that. Like these will divide out. Oh yeah, this is just straight up 4. And then if I want to find the side, I need to like get back to this scale factor, which is if I squared the scale factor, then I had the area. So I need to do the opposite of squaring it, which is square rooting it. So if I square root this, then I get that my scale factor is 2. Again, here I'm doing big over small. So if I set this equal to the side length that I want to find, doing big over small, then I can just cross multiply, which this is over 1. So 12 equals 2x. So x is 6, which I mean I kind of already knew, but that's how you find it. So that's cute and fun. Let's try some more. Alrighty, so looking at this one here, again, I know the area, and I can find the area of this one by doing half base times height. So the area of this one is 6 units squared. So I can really write the area scale factor by doing 6 over 20. So here I went small over big, just so we remember, which I can reduce that to 3 over 10. Oof. Oh, I don't know that I want to square root this. I really don't. Well, what we could do instead is just write that scale factor of the sides, so 6 over x, and then square this, and then set that equal to the area scale factor, 3 over 10. And so then what I have is 36 over x squared equals 3 over 10. And then cross multiply. So we get 3x squared equals 360. Divide by 3, so 120, and then square rooter. And that was a little bit easier than square rooting the 3 and the 10. I mean, I still have to square root 120, but at least I'm only square rooting one number rather than 2. So if I take 120 and square root it, we get 10.95-ish units because we're finding the side length. So that's a different way to do it. That's kind of fun. That's fun and different. All right. Maybe we can do that one here too. So I want to find the area of this one. It is 30 units. So if I write the scale factor of the areas, and this time I'm going to go big over small just because the big one's first. So 30 over 10. So it's 3 over 1 when I reduce, and then I have to square root it. That's not terrible because it's really just the square root of 3. That's fine. Because then I can set that equal to the ratio of the sides, so 5 over x. And so when I cross multiply here, we'll get root 3x equals 5, and then divide by root 3, which if you remember, we can't have that root at the bottom. We end up rationalizing it, which just moves it to the top, and you put a 3 under. And then that's kind of nice because I don't have to get that yucky decimal like I did over here. But, I mean, either way. And so last but not least, I'll change this one up as well just to really confuse you. If I write the area ratio for scale factor, I would do 18 over 27. And 9 will go over both, or 9 will go into both of those. 2 times here, 3 times there. And so maybe I'm going to square that back. Yeah, I'm not going to square root that because that seems like no fun. I'm going to square the sides. So if I set this equal to 4 squared over x squared so that I scale them up to meet the area, then I can just cross multiply like this. So 16 times 3 will be 48. 2x squared. Divide the 2 and then square root it. And if you want to simplify the square root and be super cute, 6 and 4 is real good because I can square root the 4 for 2 and I have to leave the 6. And then I don't have any yucky decimals. So the thing to keep in mind, guys, is when you want to set them equal, you need to make sure that you don't set area equal to sides unless you square root the area to bring it down to meet the sides, or you square the sides to bring it up and meet the area, which is usually easier to square. Square rooting is just messy. Okay, I'll see you.